Okay. The symbol for iron is Fe. Now, if you look on your periodic table, do you find a charge for iron? Nope, there's nothing there. How do we know the charge for iron? The Roman numeral tells you the charge. So that's going to be iron 3 plus. Then you go and you can look up oxide. Is oxide going to be on your green sheet or is it going to be on the periodic table? Periodic table. Okay, so that's going to be O. What is the charge of O? -2. Do those equal? No. Which one do we need more of? We need more of the O, so let's add another O. That gives us 4. Now which side do we need more of? We need more Fe now. Are they equal yet? No, so now we're going to add another O. Now are they equal? Yes, because 3 2s make 6 and 2 3s make 6. So we have a +6 and a -6. So those charges are balanced. Okay, so that's now going to be Fe. And what do we put beside the Fe? 2. And then we put O, 3. I would recommend for this section that if there's not enough space in the workbook or on your quiz, get yourself a scrap piece of paper. Do you know where the scrap paper is? Everybody point to the scrap paper. Back there beside the quizzes. Yes, very good. Okay. All right. Blah, blah, blah. So this is the most basic type of these. I'm going to let you do some practice on these, but before we do, by the way, if you want enriched credit on this, you can do this on using a periodic table without the charges listed. Okay? We are also going to do some, we call them, this is page 70. Could you turn to page 70, please? So I haven't spent much time talking about this. You don't really need to know it, but ternary just means 3 for ternary, or more elements. These are ones that contain polyatomic ions. Where do you find polyatomic ions? If you had to look up a polyatomic ion, where would you look? Yes, on the green sheet. Most polyatomic ions end in ate or ite. So if you see ate or ite, you're going to look on the green sheet. If you see ide, you're going to look on the periodic table. Okay? Ide goes on the periodic table. There's a couple exceptions to that. We'll look at them in a moment. We'll probably put a star beside them on our green sheet, but that's mostly what it is. Okay. Watch out for the names. You need to read carefully. You can't just say nitrate, because it could be nitrate, it could be nitrite, or it could be nitride. The 8 is going to be on the green sheet. And you can look it up. It is NO3 with a -1. Nitrite is going to be on the green sheet. It's really similar, but it's not NO3, it's NO2 with a -1. And nitride is on the periodic table. And it's just N3-. Remember I said most of the ides are on the periodic table. There are a couple of exceptions. Hydroxide and cyanide. Do you see how those each have 2 capital letters? If they have 2 capital letters, what type of ion are they? Those are polyatomic ions. Those are on the green sheet. Let's go to our green sheet and make sure we put stars beside them so we can find them easily. Anybody need a green sheet? We all got it? Good. Okay. Monatomic ions are like just elements from the periodic table. Yeah. Polyatomic ions are all on the green sheet. You can see at the top it says polyatomic ions. So let's look for, oh, why do I have all this nonsense on here? Oh, this must be from last year. Okay, that's all right. Well, you don't need all this stuff. It's just confusing. Okay, so let's look for hydroxide. Here is hydroxide. So let's put a star beside that one. We're putting a star beside it so you can find it because it ends in "ide," but it's not on the periodic table. Okay? It ends in "ide," but it's not on the periodic table. Let's put a star beside cyanide because, again, it ends in "ide," but it's not on the periodic table. All your other ides are on the periodic table. Actually, there's one more. Ide. See if you can find the other ide. Sulfide, bisulfide or hydrogen sulfide. So we're going to put a star beside that one as well. There is a 4th one to star, and it's already starred, and it's right underneath cyanide. What does that say? What does this one say? Dichromate. Yes. Dichromate is not 2 chromates. The dye might trick you into thinking it's 2 chromates. So you might want to write not 2 chromates. Dichromate is not two chromates. So those are the tricky ones. Anyone need another minute on this, or are we good? We're good? All right. Now, so far, you have seen compounds with brackets in them. You've seen things like MgOH2 with the brackets. That tells us that there is one Mg and there's an OH and there is a second OH. There's two O's and there's two H's. Yeah? If we were to write MgOH2 with no brackets, how many Mg's would we have? One. How many O's would we have? One. How many H's would we have? Two. So which one of those would be a correct magnesium hydroxide? This is correct. This is wrong. So anytime you have more than one of a polyatomic ion, it has to go in brackets. Okay? So do use brackets around a polyatomic when you have more than one of that particular polyatomic ion. Do not use brackets if you have only one. So if there is nothing to go outside of the brackets, if you just have one Na and one NO3, O, 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 there's no brackets. Okay? Don't use brackets if there's no number outside. Oh, that's okay. We'll get to it. We'll practice. We'll practice. Don't you worry. NO3 is a thing. NO3 is a group. Okay, if I had three NO3s, or let's say I had two NO3s, I'd have an NOOO, and I'd have an NOOO, then that would be NO3 2, because I have two of the group. Okay? It's going to become clearer after we do some examples, so don't panic yet. Okay? And you never use brackets around, what do we call it when there's just one atom? A one atom ion. A one atom ion is not a polyatomic ion, it is a monatomic ion. So if I have Cl, that's just a single atom. It's Cl minus, no brackets. Whoa. Even if I have two of them, it's just CaCl2, not Ca bracket Cl2. We only put polyatomic ions in brackets and only when there is more than one of them. Okay. We're going to skip this little bit here. And we're just going to do a couple of examples. So we are now on page 71. Sodium. What is the symbol and charge for sodium? Na plus. We have acetate. Where do we find eights? They're polyatomics. They're on the green sheet. Anytime you see an 8, it's on the green sheet. Everybody go and look up acetate on your green sheet. Acetate. Acetate is... We can go under A for acetate. It's a big long one. It is CH3COO minus. Yes. Once you've got the two ions, what do you need to do? Make the positive equal the negative. Does the positive equal the negative? Plus just means plus 1. Minus just means minus 1. Does the positive equal the negative? You guys are killing me. Does the positive equal the negative? Yes, it does. Thank you. I know you guys were telling me already. I know you were. So we don't need to do anything. We need one sodium. How do we show that we have one sodium? What number do we put beside it? Yes. Do we put a 1? No, we don't put anything. If we have 1, we don't put anything. And then we just need one CH3COO. CH3COO. Do I put a 1 at the bottom? No. Do I put brackets around it? Brackets? No, because I would need to have more than one of them. I would need to have a number to, if I needed 2, I would do that, but I don't need 2, so I do not want brackets. Yes? How do you know you don't have more than one? You look at it and you say plus 1 is equal to minus 1. You've only drawn 1, so you only have 1. Watch this. Copper, 2, Cu2 plus. And then we have acetate, which we just looked up, which was CH3COO minus. Do those two equal? No. What do we need more of? We need more CH3COO. And remember, when it says minus, that means minus 1. Do they equal now? Yes. Yes. So how many coppers do we have? 1. So we just write Cu, and we do not write a 1. And now, because we've got 2 of these, we have to put them in brackets, and we write CH3COO, and now we have 2 of them, so the 2 goes on the outside of the brackets. Yeah? Only on polyatomic ions. So if instead of acetate, let's say, for example, I had copper 2 fluoride. Okay, so I have Cu2 plus. Fluoride tells me it's on the periodic table. That tells me it's fluorine. And it has a -1 charge. I can look that up. So I would need to have 2 fluorides. Yeah. And I would write CuF2, but no brackets because it's not a polyatomic ion. It's not on the green sheet. Anytime it's on the green sheet, you use brackets, but only if there's more than one. Yes. Okay, here's a tricky one. Lithium hydrogen carbonate. There's only ever 2 ions. So this is not 3 different ions. You guys don't get to eat in class if you can't like manage yourselves. Yeah? It has been lunchtime. It's no longer lunchtime. We get all goofy about the food. We can't pay attention. Yes? So can the food go away for now? Thank you. Lithium. That's our metal. Is that a cation or an anion? That is a cation. And if you don't know, you can go onto your periodic table and you can say lithium. What the heck is lithium? Lithium is here. So it's a metal and it's +1. Lithium is +1. Li plus. Do you remember how when we had a polyatomic ion, we just grouped everything together? Everything after the metal was the polyatomic ion. Everything after the metal is the polyatomic ion. Sorry, my pen is dying here. Everything after the metal is a polyatomic ion. And that means there's going to be one polyatomic ion. You're not going to look for hydrogen separate from carbonate. Go look on your green sheet and find hydrogen carbonate. Hydrogen carbonate. And they're all under H. So basically, if you've got a hydrogen carbonate or a hydrogen oxalate or a hydrogen sulfate or a hydrogen sulfide, those are just a single polyatomic ion, and you can look them up in that H section of your green sheet. There is hydrogen carbonate. It's HCO3 minus. So we have an Li plus and we have an HCO3 minus. Does the total positive equal the total negative? Are the charges balanced? Does the positive equal the negative? How much does it mean when we have a plus? That means +1. When we just have a minus, how much does that mean? -1. So does the positive equal the negative? Ah, good point. So this is a misconception that people often have. There are not 3 of these. There's just one of them. What this would look like is it would look like a carbon with 3 oxygens attached and a hydrogen attached to the oxygen. We have one group. One HCO3. So we don't have 3 of them, we have one of them. And that whole thing has a negative charge. If I wanted to have 3 of those, I would have to say, why are you not letting me do this? There we go. Okay. Sorry, this is not behaving. The pen every once in a while does something weird. There we go. That should be better now. Think. There we go. If I wanted to have 3 hydrogen carbonates, three hydrogen carbonates would be HCO3 3. Elliot, does that make sense? Yeah? So that little 3 just means it's part of the group. So are our charges balanced here? Is +1 equal to -1? Well, I mean, obviously not equal, but are they equal and opposite? Yeah. So we only need 1 lithium, Li. Do we put a 1 at the bottom? No. And we need 1 HCO3. Do I write the HCO3 over here? Do I leave a big gap? No, no big gaps. No big gaps. HCO3. Do I use brackets? No, no brackets. Okay. Let's try one more, and then I'm going to get you guys to practice. Ammonium phosphate. Do you remember where to find ammonium? Hey, we're not done. Where are you going? Okay, and you're done? All right. Ammonium. NH4 plus. It's on the green sheet. Ammonium is on the green sheet. Go look on your green sheet and see if you can find it. Sora, look on your green sheet and see if you can find ammonium. Where is ammonium? Is it near the bottom? Is it near the top? Where is ammonium? It's near the top. Okay, if you've got a star, that's great. If you want to highlight it, there are highlighters at the back of the room. You want to circle it, that's great, because ammonium is really important and people often forget it. Okay, so make sure it is easily visible for you. Ammonium is NH4 plus. Phosphate, it ends in 8. Is it on the periodic table or is it on the green sheet? If it says 8, it's on the green sheet. 8s and ites are on the green sheet. Phosphate is PO, is it PO4 or PO3? It's 4. What's its charge? 3 negative. Do we have enough of each? Are they equal? Are they balanced? No, they're not balanced. We've only got positive 1. How do we get more positive? Add another ammonium. Did that give us enough? No. What do we do next? Add another one. NH4 plus 1. Did that give us enough? Yes. Now we have 3 positive and 3 negative. How do you show that you have 3 NH4s? We put brackets around it, and we put a little 3 on the outside of the brackets. And then we write PO4. How many phosphates do we have? Do we have 1 phosphate? Elliot. Do we have 1 phosphate or do we have 4 phosphates? Do we have 1 phosphate or do we have 4 phosphates? We have 1 because phosphate is the little group. It has 4 oxygens and we just have 1 of them. If you put brackets around it and a 4 on the outside, then you would have 4 phosphates. Excellent. Okay. So let's give you guys have listened mostly well. Lots of you have listened very, very well. Okay. Some of you listen marginally well. We need pages 67 to 69. Oh my God, so many funny numbers all at once. Now, do you have to do all of those? No, if you decide that you've done pages 67 and 68 and you get it, you can stop. You're probably ready for the quiz. So the first thing is that one. The second thing, no, you don't have to. Yeah. Pages 67 to 69, pages 73 to 75, and when you're done those, you are ready for quiz 7. Okay. Yeah. Sorry. Usually, so why are you trying to use because you're like, there's all these words and Yes. Yes.